Okay, sometimes you're given an equation like this one and you quite don't know what's happening or, yeah, what is happening. So you can actually predict what is happening when you equate the denominator to 0 and see what that function does at 0. So this is a left hand limit and this is a right hand limit. So far you've been dealing with one-sided limit, but now we're going to look at both sides of the limit. So now, okay, let's look at the left side. That's why I shared it with two lines there. So I'd plug in as x approaches 2. So you see these values are actually approaches 2 on that side, on the left side, from the negative side. So it's 1.5, it's 4, and then 1.6, it increases. So you can see the relationship actually increases exponentially until you get closer to 2. If you put it on a calculator, just put this on a calculator and say 1.955, you will see that the value, this value actually increases like to thousands or something. And if you put it 1.99, it will give you a value that's closer to infinity. So we can conclude that limit of x approaches 2 on the negative side or on the left side of 1 over x minus 2 to the power of 2 equates to positive infinity. So we can write it as positive infinity. Let's look at limit on the right side. So you can see that the relationship is also the same. These values are actually getting closer to 2. And then you see that these values are actually increasing exponentially, and approaches infinity. So we can also conclude that the limit as x on the right side of 1 over x minus 2 to the power of 2 is also equals to positive infinity. So that's the conclusion. So that means that this function, but if you see a 2 as straight, it's 2 straight, it's not defined, so it gives 0. So that means that x equals to 2 is a vertical asymptote. I don't know if I wrote asymptote correctly, but it should be close to that.